Hi, my name is John Kelly. I'm with Redox Bionutrients, and welcome to this seminar on heat stress. Currently standing in this apple block on the Redox research farm. These happen to be a Honeycrisp variety, and this is their second leaf in the second year. I'd like to talk a little bit about how plants work to enhance our discussion on what we can do about heat stress. As you know, the plant captures sunlight energy, converts that into chemical energy in the form of energy that is carbohydrates, which are made up of carbon, hydrogen, and oxygen. Carbon primarily from dioxide, water. Hydrogen comes from water. So as plants perform the process of photosynthesis, there's a process called respiration that's important to understand. Respiration essentially is gas exchange wherein the plant gives off oxygen and takes in carbon dioxide. And a key component of plants are the stomates in the plant. And these stomates are very small openings, primarily in the leaf, where this gas exchange occurs. And this process of the stomatal conductance is very important. And an idea that average plant, and it varies by plant type, the average plant will have about 300 stomates per square millimeter. And there's about 650 millimeters in a square inch. So as you can visualize these very small openings, there's a lot in that leaf. Now, one of the key factors on stomatal conductance is potassium nutrition. Potassium helps regulate the stomatal conductance. So as these plants transpire, in other words, they're pulling up water from the soil, the stomates open and close and regulate that transpiration process. About 95% of all the water in a plant is actually transpired. But in the process, that water is pulling up nutrients into that plant. So with that background of photosynthesis, respiration, transpiration, let's talk about what wilt is in a plant and what's going on inside of a plant when it wilts from heat stress. Well, in the non-woody portions of the plant, wilt occurs because of water loss. And when it's the turgor pressure in that plant is lost, that's where we see the wilt. And if it's extended, what happens is it causes cell death. It causes a lot of damage to a crop. Well, one of the challenges with heat and photosynthesis, respiration, transpiration, and wilt is if the plant does not respond well to heat, we're losing crop potential, because when the plant senses that the heat in the water wilt situation is out of balance, the guard cells in these stomata actually close. So it just literally shuts down the plant. Well, clearly the plant shuts down. What it is not doing is converting these carbohydrates into amino acids and proteins, and it's not building a better plant. So heat stress very literally diminishes the potential of the crop. For example, in these apple trees, if respiration and active stomatal conductance is only occurring for 8 hours per day instead of, say, 14, we limit of this plant, and it applies to any crop that we could talk about. So with that background, the potassium really plays such an important role in the relative conductance of the stomates, and I'd like to discuss potassium and how to better manage potassium to improve stomatal resistance and therefore reduce heat stress. Well, when it comes to potassium, we're going to talk about three key things. We're going to talk about some soil dynamics. We're going to talk about the importance of frequency and timing, and then we'll talk about some factors that relate to input selection. So first, let's talk about the soil. Soil has potassium in three key phases. The first is called non-exchangeable potassium. That's very tightly held potassium that's in the minerals, the parent material of that soil. So the mica, the feldspar has a lot of potassium. Now that potassium is not extracted in a traditional soil analysis, and that represents about 99% of the potassium in the soil. Now fortunately that potassium through weather and time releases, and the next phase is what we call as exchangeable potassium. Exchangeable potassium is potassium that is attached to the negatively charged colloids. Potassium has a positive charge, and that stage of potassium has a greater potential to convert to the third stage, which is solution or ionic potassium. And of course, what the plant makes up is that third form, the solution potassium. The key to the soil dynamic is to maintain a system wherein we get a positive release of the potassium to satisfy the plant's needs. Now, one of the key observations is potassium efficiency always appear first in soil we have poor air-water relationship. So where we have standing water, or you have water that does not penetrate well with water, soils where deficiencies are going to manifest themselves first. And why is that? Because those are soils where the dynamics of non-exchangeable to exchangeable to soluble potassium are not occurring efficiently. So that's a very important aspect of potassium management, is to have good air-water relationships, good irrigation practices, good soil health, so that we can access this potassium. The other aspect of potassium is most crops have a potassium opportunity. But we have to be careful when we make a wholesale statement, well, we want to apply more potassium. Not necessarily. We just want to strategically get better potassium nutrition. Now, why is that? Well, potassium is a cation, has a positive charge. Some of the other positively charged elements that are very important are magnesium, are zinc, manganese, copper, iron, and calcium. And what can occur is when those elements are in high demand, if that plant sees a high quantity of luxury potassium, it could throw into balance these other elements. So we don't necessarily want to put a lot of potassium on at the wrong time, especially early season when we need calcium uptake. So one of the key things about potassium is we want to feed the plant. We do not want to throw the soil chemistry into imbalance. We don't want potassium to tie up in the soil. We want to get it to the plant. So one of the key strategies for improving potassium nutrition, frequency and timing. When you can apply potassium in season via foliar or fertigation applications, that is one of the key areas to make a huge difference in the crop. In general, that potassium requirement is going to correspond to your water consumption. As your daily water consumption rates climb, that is also when potassium needs are the greatest. So we've talked about some of the soil dynamics, talked about the importance of frequency, timing, and you're going to get your best potassium nutrition with the more frequent applications, lighter frequent applications, timed when the crop can use that potassium. The third important thing about potassium is input selection. Plants take up potassium as K+, just an ionic form of potassium. And there are many plant available forms of potassium. However, some of the considerations with those potassium sources you want to look at is something as simple as solubility. How well does that input convert to an ionic soluble form of potassium? Secondly, is the anion, or the negatively charged of that fertilizer, is it something that's going to benefit the plant, or is it going to take us backwards? So you have to be very careful attached to that potassium. Is bioavailability. How well does the bond when you apply inputs? And there's tremendous differences. Some potassium fertilizers will be as high as 30 times less efficient than others. And so as you inputs that can positively affect the crop, you want to look at not necessarily units, but what is the crop response for the budget dollar. And in general, the higher end achievements progress on potassium is using higher input potassium or higher efficiency input potassium products, applying them at much lighter rates, more consistently during the time when that potassium can be utilized by the plant. So in summary, there's real opportunities with potassium. Potassium plays a critical role in heat stress and enabling that plant to deal with heat stress. And if you consider soil dynamics, consider frequency and timing and input selection, the possibility of making significant improvements in production and quality are there. Thank you for your time. Please email us or contact us via social media with any of your comments or questions. Thanks.